Okay, now we're going to look at harmonic equations. Okay, and in question 1 here, it says express 3 cos x plus 2 sin x in the form r cos x minus alpha. Okay, where r and alpha are constants with r greater than 0 and between 0 and 90. Now, because they want us to express it in that form, that's the form we should be using, we need to use the result from the formula booklet, okay, here. So we're going to rely on that. We don't have to memorize it, we're just going to use it. So when it says expressed, right, so let's go for it. 3 cos x plus 2 sin x in the form, so we put it equal to r cos x minus alpha. Okay, what you should do then, right, on the next line is write r and then big square bracket, okay, and we're going to now expand cos x minus alpha using this from the formula booklet. And quite simply, you replace the a with the first term there, the first letter there, which is x, and you replace the b with the second letter there, which is alpha. Okay, and because it's minus in here, we need to choose the bottom option, okay, in the compound angle rule. So it'll be the same here then. We're going to choose the bottom option in our result. Okay, so when I express it out in full, I got cos a, okay, which of course remember is x, cos b, which of course is alpha, and because I'm choosing the bottom, it'll be a plus, and then I've got sine a, so sine x, sine alpha. Okay, and you notice then it comes out plus nicely, which has got to be the same as this side, right, in the questions. It's got to correspond, so it works out nicely. What I'd advise you to do then is on the next line, maybe we'll write this out again, 3 cos x plus 2 sin x. But when you expand this out here, so you can do r times this, write it like this, so r cos alpha cos x. Okay, so just swap them around, okay, when I multiply it. You're allowed to do that, because, you know, multiplying is commutative. It doesn't matter what order you do it in, okay, so just swapping them. And the same now, when I do r times this here, I'm going to write it as plus then r, so I'll swap these around, sine alpha, sine x. And what you should do then is we're going to sort of equate both sides. You're going to realise then that this has got 3 cos x plus 2 sin x, and similar sort of makeup here. We've got this r cos alpha cos x, r sin alpha sin x. So we've got a cos x as we've got a cos x here, and a sin x as we've got a sin x here. And if they both equal, what that means is what's in front of the cos x here, which is r cos alpha, it's got to equal what's in front of the cos x there, which is 3. So r cos alpha is equal to 3. And similarly then, what's in front of the sin x here, which is r sin alpha, has got to equal what's in front of the sin x there, which is 2. So r sin alpha is equal to 2. Okay, so I've got myself an equation 1 here, equation 2. And what happens when you divide them, right? And in fact, we'll divide them, but we'll divide them the other way around. So we say that r sin alpha divide by r cos alpha. Okay, in other words, 2 divide by 1. Okay, second divide by 1. We'll do it that way. So if I've got r sin alpha divided by r cos alpha, I'll have then 2 divide by 3. Okay, comparing the other sides. Now what happens, of course, is that the r's will cancel. Sin alpha divided by cos alpha then is tan alpha, 2/3. And then I can work out alpha from there. Okay, so to work out alpha from there, of course I've got to do tan to the minus 1 of 2/3. And I get 33.69, okay, and then I got a few zeros, so I can write the answer like that. So that's what alpha is, okay, I've found alpha. To get r, what I want to try and avoid is substituting the angle back in, okay, because there's a better way of working out r, so you get an accurate answer, okay. And the best way to do that is to square both of these and add them, okay. So it's basically doing Pythagoras. So if I do that, okay, 1 squared add 2 squared, okay, well essentially I'm going to have r squared cos squared alpha equals to 3 squared. So if I'm squaring all of 1, I get that. If I square all of 2, I get r squared sine squared alpha equals to 2 squared. And as I said, you can add them. So if I add them, okay, well here I'm going to have r squared cos squared alpha plus r squared sine squared alpha. So adding that to that, get this, and then 3 squared plus 2 squared on this side. Now what you notice here then is we got a common factor, yeah, of r squared. So I can factorize that out. So r squared, bracket then. So r squared times cos squared alpha and r squared times sine squared alpha will give me this. On this side then I've got, what's that, 13. Now cos squared plus sine squared of course is just 1. So r squared is equal to 13, which means r will equal to square root of 13. And we take the positive root, because when you square root of course positive and negative, but we take the positive because it says in the question take r to be greater than 0. Okay, so then quite simply then to finish off, to express this 3 cos x plus 2 sin x, well remember it's got to be of the form r cos x minus alpha, where r is positive, so root 13, and x is between 0 and 90, so 33.69. And we've expressed this in the form that they want.